shifting graphs and transforming them.
Dude, I was just doing that with Patty yesterday, bro. Where
I
were you,
know.
dude? Where were you, man?
Well,
I
I
was
thought it
late
was
though.
like
You're
at
probably at
5
hockey
o'clock.
practice or something.
Yeah, I think.
I think you were at hockey practice.
I think you did it later because you
I
delayed it.
did, because I had to pick up my friend from the airport. They're playing. Oh, you already got the question up there, dude. Look at that. Where is Doctor
Probably need to do a
Gold?
couple. Then.
No idea. Doing whatever he does, teaching someone probably. Where's Doctor Gold? Yeah. Today's Wednesday, right? I'm supposed to come on at 4, right?
Yeah.
Yeah, there you go. Mega Max with the first with the cat. What's up? Okay, cool. All right. Man, I literally just did this. So you know what I'm doing? I'm not even gonna write it again. I'm just gonna show it to you. Okay. Let's put this on a new page. Actually, here I can get rid of this. Let me show this.
All right. So we basically today in class we learned multipliers,
Uh-huh.
and we learned like what they do to like transition,
Good.
horizontal.
Yeah, good. Okay, so here we go.
This is simpler stuff that I just want to quickly master before I go over.
Here,
more
I'll
advanced.
go over. Oh, let me share the Discord. Sorry, my bad. Okay. Yo, what's up, Mango, dude? Good to see you. I haven't seen you in a bit. Haven't seen you in a minute, Mango, dude. What's good, bro? What's good, Mango? Okay, so, oh, then let me tell everyone we're live. We are live. I'm joining. Learn some shit. Okay, here we go. Okay, so Philip, we always have functions, right, that have like some sort of transformations, and then we have the parent function, right, which is what they look like before they get modified, right?
Mhm.
Okay, so let's look at
The square root is 1, 0, 0, 1, 1.
Yeah, those are what the points are. But like first, this is what I did showing to Patty. Like, yeah, sure, you could just start like plugging points into shit. You know, yeah, you totally could do that.
That's how I usually start off.
Yeah, no, it's better to know what the graph of the original unmodified parent function looks like, and then to see what's happening to it. Okay.
Mhm. Yeah.
So let's say, for instance, we had something that was just like the square root of x, right? And then let's say we had square root of x plus 3. Okay. The thing you need to know is that anytime something happens like within like the square root, or for instance like within like the square
Within
or something.
like the function.
Pardon?
Or like within like the absolute values.
Good, yeah,
Just, like,
within whatever the function is, yeah. That's all.
It's the inverse, right?
Well, okay, so a couple things. First of all, that's all the horizontal shit that happens. Okay, so here.
Okay, that makes sense.
Here, do you see here? Like, this is, for instance, what you could have. Like, if you had an original function that was just y equals the square root of x, here's all the modifications you could have to it, right? I could multiply the x by something. I could subtract it, h from it, right? Like, within the square root. And then I can do stuff outside, right? I could, again, multiply, or then I could, like, add,
See, that was one of the things I couldn't tell is which one was a horizontal and vertical.
Okay.
So anything inside is
yes.
horizontal.
Yes, anything. What's up, Ash? Good to see you. Good to see Smoothbird, too. What's up, guys?
So on the example to the right that you already have negative x plus 3. Though that everything is only a horizontal.
Good. Everything is only horizontal stuff that's happening. Okay. Yeah. Okay. So then okay. And also the stuff within horizontal is flipped. Okay. So like usually you think like plus would go to the right, but it's not. Plus goes to the left.
No, that's the inverse I was talking about.
Inverse. Okay, cool. It's also the same thing with the multipliers. Okay. Usually when a multiplier is greater than 1, we would think it stretches it in whatever that direction is.
No, it shrinks it because it's reciprocal.
Thank you. Okay, you already understand this. Okay, whatever. Cool. All right. So then, what are you confused by?
I just want to like. Okay,
all
so
right.
mainly.
So here. Let's look at this, for instance. You tell me everything that's happening on this bitch.
Okay, so we have a multiplier. Oh, let's.
Okay. Oh, here's also the rule. Here's also. Do you know the order in which
Shift
you do the
has to go last. Shift is always last.
Pardon?
Shift is always last.
That's interesting. But
that's
like which? But which? That's
last.
what they tell you. They say like.
Yeah, that's what they tell me.
Kevin, you're.
And then my teacher says vertical or horizontal doesn't matter, but just make sure the shift is last.
He's okay. So I don't agree with that. Really, because like it's like which shift, right? Because technically there's a horizontal shift and there's a vertical shift. Like
he just says that there's like multiple, like you have to like move it up and down or like flip it, and then you have to shift.
So here's my rule. Here's my rule. Okay. You need to do whatever is happening to the x first. That's the order of doing things. Okay.
Okay.
So when I look at 2x minus 4, right? What's the first thing that's hitting the x?
The 2.
2.
The
Good.
multiplier.
See how they multiply by 2? And actually, this is interesting because, like, I don't know why I think that the 2 is hitting it before the minus 4 is, but that just, like, intuitively makes sense to me. Does that make sense to you? Like,
Yeah.
yeah. Can I cash my bond coins in for a simularium tick? Yeah, sure, man, dude. Let's see. Okay. Megamax. Ooh, Megamax getting on the 500 coins. Nice. Okay. So yeah. So this is first, right? And so what's happening here with the 2x? What happens to it?
So for a vertical, it is shrinking
No, this is
by
not
a factor.
vertical though. No, Patty. It's not Patty.
Well,
Sorry.
horizontal.
This is horizontal, right? Because we're within the square root, right?
Yeah.
So this is horizontal.
So it's doing a horizontal shift.
No, not a shift. What does a multiplier do?
Shrink.
Shrink. Well, why is it a shrink?
Because the reciprocal of 2.
Reciprocal of 2. So this is a horizontal shrink.
A factor.
By
factor.
By a half. Or factor of 2.
Yeah, by a factor of 1.
What are simularium ticks? Simularium ticks is Megamax. That's the festival I'm throwing this weekend. If you were in Los Angeles and of legal age, you could come out to the desert for the festival I'm throwing. But yes, that's what simularium is. What is MT anyways? MT are the coins that are used for the monthly tournament that we're participating in Warzone. You can read more about it in the Discord. All right. Okay. What's the next thing that happens?
So also another horizontal movement is a
Good
to the right 4.
Good. This is to the right 4. Good. So we're gonna say right 4.
Transformation.
Right to the 4. Good. Okay. What's the next thing?
And then we can just do what we can list the verticals.
Yes. Now we can list the verticals. But which one hits first on the verticals?
The negative 1/3, right?
Good. Negative 1/3. Good. Perfect. This is right. So what is that negative 1/3 gonna do? Because that's actually a combination of things.
So it's not the opposite, right?
No, because we're outside.
So that is, since it's smaller than 1, it will make it larger.
No. Smaller than 1 shrinks it.
It's the opposite.
Well, inside it's the opposite, right? So inside, like, big numbers shrink, and small numbers, like fractions, make it big.
So now smaller numbers will make it shrink.
Good. So this is what type of shrink? What type of compression is it?
Vertical shrink.
Good. So we say vertical compression by a third.
Vertical compression by negative 1/3.
No, just say by a third, because that negative is something different. That negative is a whole other thing. What does the negative do?
No clue.
Haha. Negatives are reflections. Okay. This is what I show here.
Reflections over to X or Y.
Good. Yes. So
wait, can we quickly go over what's the difference?
Yes. Okay. So a reflection. This is an example of a reflection. So if it's outside, it's vertical.
If it's negative F, then it's X, and then if it's just F of negative X, then it's over to Y.
Correct. Right. Yeah. So you're talking about, like, negative F of X versus
X, that's
F of negative
F
X.
of negative
You see how
X,
also this is like inside, like this is like inside the
Mhm.
shit. You know, this is another example where this is a horizontal thing. This is a horizontal reflection.
I have a question.
What's Manga? Let me answer this real quick, and then or do you have a question about this? Is that your question?
Yes.
Okay. What's your question, bro?
What grade is this for?
Oh, this is probably 10th grade.
Oh.
Yeah. So it's okay if you don't get it, Mango, but, like, you can watch it and see if you pick stuff up from it, because I know you're only in what, 5th grade, 6th grade?
5th.
5th. Yeah. So you'll eventually get to this, but just you can just watch it and then see what you pick up from it.
I'm gonna pay close attention to this because I have 5 years to get prepared.
You do have 5, dude.
This is the start.
Yes, dude. That's dope. That's dope, Mango. I like that. All right, Philip. So yeah, so this is horizontal because, again, we're doing stuff within, like, this with the example would be like this, whereas this, for instance, would be outside. It would be like that. So this is vertical reflections. And yeah, the way they say it, right, is a reflection over the axis or whatnot. I'm just like, did I flip it this way or did I flip it this way?
Yeah.
Right? This is a vertical reflection, right? So in this case, since this is outside, you're going to reflect it vertically. However, this is an important thing that I was showing to Patty, is that the order of what happens counts, all right?
Yeah.
So when we look here, right, see how we have a down 4 and we have a vertical reflection? Which one am I going to do first?
Vertical reflection.
Good, yes, because this is closest, right? Yes. So you see how it's important to reflect it first and then drop it down 4, okay? Because if I dropped this down 4 and then reflected it, right, it would look like
then
this.
you'll get a whole different graph.
Good, exactly. So this is where it's important to realize you got to do this first, and then you got to, right. Okay, but so here, in terms of like the compression and the flipping, it doesn't matter which one you do first, because they're like baked in together. It's like a cake got like smushed or something, you know. So what is this negative gonna do?
Negative is make it reflect over to x.
No. Yes. Yes. I would just say vertical reflection.
Or vertical.
Vertical reflection. Or I think actually your teacher probably actually does want you to say over the x-axis. Okay, final thing. What's the final step? What's up, Obama? Good to see you, bro.
And then the +6, which is it's going to be another vertical shift. It's going to make it go up 6.
Vertical up shift. So this is going to be up 6. Good. Up 6. Cool. Awesome. All right. Oh, this was Patty asking me, like, why the fuck are we learning this? And I'm like, well, you know, when you throw a ball, that's a parabola. And it's cool if so, for instance, throwing a ball is something that follows a physics formula that looks like this. It's the initial height plus the velocity times the time plus 1/2 times the acceleration times the time squared, which really just looks like AT squared plus BT plus C. And this is a quadratic, right?
Oh, yeah. Also, for my course recommendation, I chose AP Chem.
Yes. Good. Nice, dude. Dope. Yes. AP Chem is correct.
I'll just take AP Physics 1 senior.
Senior
or maybe
year?
I can take...
No, you can take C, dude. Take AP Physics C senior year. It's not hard.
Maybe,
Yeah, dude, you got it, bro. If not, I'm here, dude. Zach, good to see you, dude. It's all right. You're 10 minutes late. No, you're here, dude. There's no such thing as being late. No such thing as being late to office hours. Actually, you know, do you guys even know what office hours is? Do you know where, like, that name comes from?
The Office?
The Office? Close. Have you... Okay, so office hours... Maybe you guys don't know because you guys aren't in college yet. But in college, you have classes, right, that you go to. And then...
Yes.
Afterwards, at different times during the day, the professor will hold what is called office hours, which means you can come to my office and I'll be there for an hour, and you can come in at any time during that hour and you can ask me a question and I will help you out with it. That's what office hours are.
Okay.
Yeah, so
Never knew it was a thing.
Yeah, no, it is.
Never heard.
Your teachers may do it in high school. They probably won't call it office hours. Do your teacher ever have, like, you know, hey, you can come ask me a question during lunch or some shit? No?
Yeah, there was something called seminar.
Seminar,
But then
okay.
they got rid of it.
Okay, cool. Well, in college, it's, like, required, because this has been, like, a tradition for, like, decades, is that professors have to have office hours. Like, they have to have an hour at least a week where they're just in their office and people can walk in and ask questions. And this is something I never took advantage of in college, and I really wish I did. So, because there were a lot of times where I didn't understand shit in class, and I didn't really want to go talk to the professor about it because I was afraid that I would look dumb, which is the dumbest thing ever. You should never be afraid of looking dumb. Like, you should just go in and just ask. So I would try to get my friends to help me, but, you know, would have been better if I'd actually just gone into office hours with my professor and actually had my professor. So, yeah, that's a little tip for you guys. When you get to college and your professor has office hours, go to them. Like, it's useful. All right. Sorry, Philip. Does that?
I have a question.
Wait, one sec. Let me get Philip. Philip, does that answer all your questions? Yeah.
Yes.
Okay.
That's a little more better. Yeah.
Good. All right. Cool. Mango, what's your question, dude? I gotta answer Nolan's. Do you have a screenshot of what you need help with?
No, but I have kind of like a description.
You have a description. Okay. Can I answer Nolan's question real quick? Because his is next up in the queue, and then I'll do yours afterwards. Is that cool?
Okay.
How many bond coins am I at?
You're 42. All right, Nolan, you here, bro?
Ooh.
Yeah.
Bruh. Okay, nice. Find the length of CD. Ooh. Oh, okay. This is kind of cool.
I have my Unit 2 test tomorrow, or actually in 2 days.
Okay. Interesting.
Gotta get prepared.
You gotta get prepared. Okay, how do you think you do this one?
I've done something like this before.
Have you, Mango? Yeah, it's like triangles.
No, what's the... actually, I'm not going to say a thing.
Yeah, it's all right. Let's just, yeah. I like people to try and figure it out.
You need to solve the bottom left side, right?
Yes,
Or
you
like
do need to solve this, right? Yeah, it would be nice if we just solved this triangle, right? Because that would make things probably pretty easy.
Math teacher's favorite theorem.
Math teacher's favorite.
So then
Really?
use the Pythagorean theorem.
Good. Yes. Use the Pythagorean theorem. Yes. To figure out what?
You say Pythagorean or Pythagorean?
Pythagorean. I don't know, dude. Like,
It's a weird word.
Okay, so how do I do that?
So x is gonna be the greatest side, or the longest.
All right, we can call this x for sure.
Yeah. So it'd be x squared
Mhm.
equals 8 squared plus 6 squared.
Good.
Okay.
So what does that mean?
What's 8 squared?
Yeah.
64.
Nice.
6 squared.
And then 36.
Good.
Add them together.
Yes, dude.
100.
So
100 was square root of 100.
10.
10. Good job. Good job, guys. I like that. I like the teamwork.
You just want to you should be at the end of the year, you will realize that 8 and 6.
Yes. Yeah. No, I was about to say this, but yes, thank you, Philip. Yeah. What you about to realize? So what Philip is, and actually here let's do this at the very end, or actually no, let's do it now. Okay. So Nolan, your teachers are lazy. Not that they're lazy. Sorry, they're busy. They have a lot of things on their plate, right? They're having to deal with teaching more kids than ever, and now they got to deal with not getting COVID and whatever. So when they do questions like this, when they create questions like this, they're gonna end up using very specific triangles, which are called the special triangles. And if you can recognize what special triangles they're using, you don't even have to do any of this. It's like cheat codes. You want to know the cheat codes?
Yeah.
Okay. Here are the special triangles.
Is it the triplets?
Yes. Good. Yeah. What are the triplets?
I don't know. Our teacher explained them for 10 minutes. I did not understand it.
Okay.
He said most people aren't going to use it.
What? No, you could. I'll show you right here. You can use it in this one.
All the time.
Yeah, use it all the time. All right. There's 3, 4, 5, and 5, 12, 13. Have you seen these numbers before?
Yeah.
Yeah. Okay. So what this means is that if a triangle has two small sides, 3 and 4, and it's a right triangle. Sorry, first of all, these are right triangles. They have to be right triangles. Okay. Then the hypotenuse, the biggest side, is gonna be 5. Okay. And then this is the other one you should know, which is 5, 12, and 13. And now there's a special thing about triangles that you may have not gotten to yet in geometry, but what do you know about are they called similar triangles? Is that what they're called, similar triangles? Have you done similar triangles yet, Nolan?
I don't think so. No.
Similar triangles are triangles that have the same angles, but they have, I think, different side lengths. Yes, good. Yeah.
I don't know what I called them.
I think we call them something else.
I think these are called similar triangles or congruent. No, congruent would be same side and same angle.
Yeah.
So let's say we have an equilateral triangle, right? That's 6, 6, 6. Oh shit, it's the devil. All right, where everything's 60 degrees, right? I could make this triangle bigger, right, by just multiplying all the sides by the same number. So let's say I multiply everything by 3. Okay, so now it's 18 by 18 by 18. Okay. This is these two triangles right here. These are similar, is what they are. Okay. Because they have the same angles, right? 60, 60, 60. The only difference is the side, right? And this is what they call this. This would be called a have you seen the word scale factor before?
Yeah, I think so.
Okay. Have you ever done model cars or shit, or I don't know, model airplanes?
I feel like I used to do this in middle school.
Yeah.
No, you have an RC car?
Yeah, RC car. Yeah.
It has 1/16.
Yeah, there you go.
1/36.
Yeah, here, model car kit. This is what I'm talking about. You ever seen? Let's see. They'll probably do something.
Really build one?
Yeah, you ever built one of these?
Yeah, I've done one before.
Yeah, right. These are pretty cool, right? Do you see where they say scale 1, 25,
Okay,
right?
I am back.
Nice, Mango. Well, I'm almost done. See where this says scale? Sorry, you can't. This is so small. Jesus. Okay. No cookies. You see how this says scale 1, 25?
Yeah.
That means that every for instance, every 1 inch on the model is equal to 25 inches in real life. Okay.
What?
Yeah.
Basically, a smaller ratio to bigger.
Yeah. So basically this car that you make is 25 times smaller than what it actually is. If that makes sense. Okay. Cool.
Pretty cool.
So that's what's happening here with a triangle with a scale factor is we're literally just multiplying all the sides by a certain number, right? And This is also applicable on special triangles. So if I have a triangle where two of the small sides are 3 and 4, and then the last side is 5, I can also do multiples of this. Multiples of these also exist. Okay. So what would be a multiple of 3, 4, 5? Wait. I heard a couple people.
Multiple, like.
Okay. So like let's say like this is a triangle, right? Which is gonna be 3, 4, 5.
Mm-hmm.
What if we scaled this up by like a factor of 2?
Factor of 2?
The triangle.
2.
Yeah.
So
what would it be?
4 would turn into 8.
Good.
3 would turn into 6, and 5 would be 10.
Good. Do you see how this is the same thing here?
Yeah.
So what you should do when you recognize this is you should be like, oh look, this is this is 3 times 2. This is 4 times 2. That means this one must be 5 times 2.
5 times 2.
Good. Nice, guys. Yeah. Does that make sense?
Yeah.
Cool. All right. Okay.
I'm getting this stuff.
You're getting this? Okay, good, man. Good. I'm glad you're getting this. Okay. So, does that make sense to you, Nolan? Because I know your teacher explained it to you last time and you didn't make any sense. Does that make sense to you? Like, you're just looking out for things that have that pattern. So here's a good example. Let's say, for instance, I had a triangle that say looked like this. What would be the missing side without doing the Pythagorean theorem?
Whoa.
Because this would suck to do the Pythagorean theorem. I don't want to do 16 squared. I don't want to do 20 squared.
Wait, is it going by 2s? Like multiples of 2s?
Close. So let's remember what our special triangles are, right? 3, 4, and 5. 5, 12, and 13. Does this one look like it follows any of the patterns?
I know.
The 4.
Good. Isn't it going 4?
It is the 4. It's this one. Okay, but what it does follow this one, but by what factor?
4 and 5.
4.
Good. 4 and the 5. Yeah. So you see how this one, and this is 4 times 4, and this one is 5 times 4. So what is this one gonna be?
12.
Good.
Wait.
6 times 4.
No, it's gonna be
Actually
3 times
3
4.
times 4.
Good.
Wait, so I got it right?
You got it right, Mango. Yeah. Well, I want to make sure you know why you got it right. But yes, do you see how this is 3 times 4, 4 times 4, 5 times 4? It's just 12.
Because the numbers are 3, 4, and 5?
Good, yes. And then they're all multiplied by a factor, right? You see how that becomes 12? See how 12, 16, 20 is basically 3, 4, 5, but times something else?
Yes.
Yeah. Does that make sense, Nolan?
Yeah.
It's okay if it doesn't. You tell me if it doesn't.
No, that makes sense. I just feel like the 5, 12, and 13 would just be confusing.
Okay. Well, here's your time to shine, dude, because here is another triangle. So now we have these two sides, right? And we try to find this side. This is the final side.
Mm-hmm.
Okay. Let's look at these sides. Do these things seem to follow any sort of pattern that we know?
With the triples?
Yes.
13.
Good.
Wait, no.
Close.
Well, both of them aren't.
Wait.
So look, we got a side that's 10, and we got a side that's 26.
What times 3 could give me 10?
Well, nothing, right? So it's not going to be that one. What if we looked at this one, guys? What if we looked at this one?
I had 12, 13.
Yeah.
So
yeah, Nolan. I want Nolan to answer it.
Okay, so 5 correlates to 10.
Like
good.
And 12?
13 correlates to 26, and then 12 would correlate to CD.
Good. So then what would CD be?
6.
No.
4?
No. So this was 5 times 2, right, which was 10. This was 13 times 2, which is 26. What's the missing side in a 5, 12, 13?
5, 12, 13.
Right. See how we have 5 times 2 gets me my 10? Good.
No.
Yes. This is 12 times 2,
Oh,
Nolan.
for
Do you see that?
12?
Yeah, you did divide by 2, Nolan, right? Yeah, it's really times 2, right? Do you see this, Nolan? Do you see why this one's going to be 24?
Yeah.
Yeah. I know you saw the you're like, "Oh, it's dividing by 2," but no. This 26 was because the 13 got multiplied by 2. And this
I
10
thought you said it was lower by triple.
Well, no. So it's this is when we say triplet, it means there are 3 numbers that like correspond. That's what this is. Right.
Now I know what Now I know what that
Good.
is for 5.
Good. Yeah. You are right, Nolan, that honestly, like, usually this one will not be used as much because these sides start getting ridiculously big if you start multiplying by stuff, right? Like, the next one would be 15, 36, 39, right? That's a big triangle. But this one gets used all the time, dude. The 3, 4, 5 gets used all the time. So it'll really
teachers are lazy.
because they don't want it, because doing this, guys, this takes a long time, dude. And like we only have so much time on this earth that like teachers don't want to go like doing this all the time. So what they do is they use like shortcuts. They use these 3, 4, 5 triangles where they can easily figure out like did you get the right answer or not, you know, because they just look it up. They're like, oh, this is just 3 times 5, 4 times 5, 5 times 5, whatever, you know. Does that make more sense, Nolan?
Yeah.
Yeah? Cool. Nice. Good job, Nolan.
I'm understanding.
Good geometry question.
Now.
Good job, Mango, dude. Yeah, good job, dude. Mango, this is not easy, dude. This is geometry, which is usually ninth or 10th grade. I took it in 8th because I'm a super smart nerd. But
cool killer.
Geek. But
Geek Squad.
Geek Squad, dude. Nerd Squad.
In 4th and 5th.
Yeah. Mango, what math are you taking right now? Are you in 5th grade, Mango? What math are you in?
Standard algorithm, multiplication, and division to like 600.
Are you in 6th grade? I forget. What grade are you in, dude?
I'm in
5th grade. Okay, cool. So when you get to 7th grade, you should see if they can, because Mango, you're honestly a pretty bright kid. You should see if they put you in algebra for 7th grade. That's what you should do. So.
Wait, what is algebra?
What is algebra? Algebra is solving for variables. Algebra is the science of not the science, sorry. The math of figuring out what unknown variables are. Figuring out numbers you don't know. That's what I would call it. Don't call him a geek. He talks to girls with confidence. I used who is it? I used UT Statics pickup line on a chick. Did you guys see that? I did do that.
No, you didn't even use mine.
I used UT Statics. I know you were, but I the girl didn't really speak very good English, so I couldn't really give her a math joke. I had to go with something that she understood, which was just parking fines. I wanted to have some chance of like continuing to talk to her. But I like yours mechanical. Your pickup line is dope. I am gonna use that on the next one. Don't worry. But yeah, if you guys don't know, it was I think it was it last Saturday or something? I said the first 5 people to follow or subscribe to the YouTube get to pick my pickup lines for that night.
Yeah.
I still have yours, guys. I have mechanical. I have yours saved in my phone, so like I will say it the next time I'm at the opportunity that I do that.
Also,
What's
I have
up, bro?
a math question.
You got a math question?
Going.
Mango had a question next. Mango, what was your question? You were next in line. Mango, what's up?
I need help with stuff like long division.
Cool.
And stuff like that.
No, that's fine. Yeah, I did long division with Jack 2 days ago, so we can do it again. All good. Okay. When do you use long division, Mango? When do you use long division?
Like when?
Yeah. Like why would you need to use long division? I'll tell you. It's when you have to divide like really big numbers, you know? Like let's say Mango, if I ask you what like 35 divided by 5 is, what is that?
7. Oh shit, my fault.
It's okay.
Well, I know that because 5 times 7 is 35.
Good. Yeah. Okay. You know that one. That one's easy. Okay, what if I told you what's 64 divided by 8? What's that one?
That's 8.
Good. See? Nice. Okay. What if I said 6,437 divided by 6?
Wait a minute.
He's like, oh no, how am I going to do this?
It's a decimal.
It is a decimal, but it actually could be like a fraction. But this is an example, Mango, why you need to use long division, right? Because I can't do this shit in my head. And, like, let's say I don't have a calculator with me. You know, that means I got to go do it the long way. All right. So here's how you do long division. What we're going to do, Mango, is we're going to build a house, okay? Houses are really nice. It's good to have shelter. It's very expensive to build a house right now in America because the price of lumber is so expensive. But
because everybody's chopping down trees.
well, yeah, then no one's going to work because no one's paying people enough money to go work. But yes, so what you
Schools and offices use the most trees.
do they? What, with all the paper they use?
Yes.
I could believe that. Okay, so I build the house, right? And then what I'm going to do is I'm going to put the number, the first number. So if I'm doing blank divided by, if I'm doing like A divided by B, right? Whatever this first thing is, I'm going to put inside the house, okay? And then whatever I'm dividing it by, I'm going to put outside the house. Okay, I'm going to put the 6 over here. All right? Do you know what to do next, Mango?
Yeah.
What do you do next?
Well, the way my mom taught me was you would do how many times does 6 go into 64?
Ooh, interesting. Okay, so I want to actually attack these one by one is what I'm going to do. That's a cool way to do it, but we don't really need to do that yet. Here's a better way to do it, Mango.
10.
We're going to do how many times does 6 go into 6? Okay? How many times does 6 go into 6? Once. Good. Nice. So what I'm going to do is I'm going to say, okay, 6 goes into 6 one time, right? Which means I'm going to put a 1 above this 6.
Up there.
Okay, and then what do I do next?
Then you multiply 6 times 1.
Good. And what do I get?
And then you put the answer down.
Good.
Which would be 6. And then you do 6 minus 64, which would give you 60.
No, so not yet.
Which would give you.
So I'm going to do 6 minus 6. I'm going to subtract these two and I get 0, right? The next thing I do is I'm like, okay, how many times does 6 go into 4? Sorry, here's what I do. I ask, how many times does 6 go into 0?
0.
Right. Yeah, it goes. It doesn't go in any amount of time. So actually, what we got to do next is we got to bring down the 4. Okay. How many times does 6 go into 4?
It doesn't.
It doesn't. Okay, that's when you're allowed to write the 0. Now you write the 0. Okay. It's only so it's after you've done the subtraction and then you've tried to pull down another number. That's when you get to write the 0 above that number. Okay. Okay. So then what do I do next?
Okay. I think you would do. How many times would 6 go into 3?
So not yet. So here's what we do. We got to do the 0. Do you see how here when we said 6 goes into 6 one time, and then we do 1 times 6 equals 6? So we had here, how many times does 6 go into 4? We said 0 times. So now we got to do what times what?
6 times 0, which would give you 0.
0, good, yes. And then we got to write it here, okay? And now we got to subtract.
We do minus.
Good.
Which would give us 4.
Good. How many times does 6 go into 4?
0.
Okay, so then I get to do what?
Bring the 0. Put down a 0.
No, bring down the 3. Bring the 3. Bring down the next number. 3. Okay. Now I ask myself, how many times does 6 go into 43?
7 times.
7 times. Good, dude. Okay. Next step.
If you know your if you use a multiple tower, you would know that 7 times 6
Math
is 42.
Murpher. Good, 42. So yeah, so what I'm going to write the 42 here, right? Because I'm going to do 7 times 6, okay? Now what do I do?
Yep. 42 minus 40, 43 minus 42, which would give you 1.
Good. Okay. Does 6 go into 1?
And then it doesn't go in there at all.
Yeah, so what do I have to do?
Put this 7 down.
Pull the 7 down, right? Okay, now what do I have?
Yeah, that makes 17.
How many times does 6 go to 17?
6 goes into 17 twice.
Good.
2 times.
Okay. Then what?
And then you put 12 down because
6 times 2.
Pretty sure you have to do 6 times 2 and then you put the answer down.
Mm-hmm.
And then 17 minus 12 is 5.
Good. What do I do with that 5?
Right? Wait, what? And then that's the I think remainder.
Good. Yes, this is the remainder. We would say the answer. So the answer we would say is 1072 remainder 5. I think is how they write this with an R.
Yeah.
You want to know an even cool?
I'm back.
Nice, Mega Max. Sorry, not Mega Max Mechanical. Dude, you guys both have the mech name now. Now this is like messing with me.
Change your name, Mega. I'm not playing with you. Word to my homie.
All right.
The first mech here.
All right. Okay. So wait. So here's another cool way you can write this. Instead of writing remainder 5, Mango, what you can do is you can write this as a number and a fraction. Do you know how to do that?
No.
So what we're gonna do
like
is yeah.
Like when you write 5, like right next to the number, like up top of it.
So instead of saying remainder 5, I'm gonna say plus, and then I'm gonna say this divided by this. So I'm gonna say plus 5 over 6.
Oh.
And this is the full answer, is what this is. It's 1072 and 5/6. Yeah.
Oh.
Remainder 5 means you have 5 left over, but what it really means is it's whatever the number was plus 5 over 6. Like whatever this number is here.
Yeah.
Does that make sense?
Kind of.
Kind of.
I'm getting the hang of this now.
Do you want to practice? Here, we'll do one more practice question. We'll do a practice question for you.
Okay, wait, can I go get a paper so I can like write it down?
Yeah, go get some paper. Go get some paper.
Oh,
Mega awesome. Mega big dick 69. No, you can't be mega big dick. You can't be mega dick big dick 69. Oh man. No one's made me drink yet today. What's wrong with you?
I'm not getting any channel points for some reason.
You're not getting any channel points?
Yeah, I should get 450 for watching it in a consistent streak, and then I should also get 50 for watching it for 15 minutes. Alright, let me rejoin the Twitch stream.
Yeah, maybe that's it. Thank you, Bomby Boy. I appreciate the hydrate.
Bomby Boy, sir.
Bomby Boy is so fake.
Bomby Boy's in the chat, dude.
He redeemed the whole bond coin and was just like, you know what? Take it, Mega Max.
Did he? Did he do that? Did he really do that? I'll have to check. I haven't been checking the chat the entire time. All right. Mango, here. Let's do this question. All right. Are you ready for it?
Yeah, I couldn't find any paper.
Oh, okay. It's not like an envelope like laying around.
I will pop in and tell someone to say something to make me happy, and first
one
I'll
to
get a
get a
bond
coin. Okay.
I said it first. It's just that the message got sent late. I should get one too.
Let's do 700.
I got some paper.
You got some paper? Good. All right, let's do this, man. Let's do 7,942 divided by 9. We're gonna make it a little tricky. Cool. You there, Mango?
Still don't know why I'm not getting no MP points, but okay.
What's up, Mango?
I'm talking to my mom.
You're waiting for your mom?
I was talking to my mom.
Oh, okay. All right.
Some paper for accident. Alright, I got the paper.
Okay, you ready?
Yep.
All right, so let's do this. Let's do 7,942 divided by 9. How do we do this?
How do we do that?
Yeah, we got to do long divisions with this.
We're going to make a house.
Let's make a house. I like making houses. Okay, cool. Make a house. And what am I going to put inside the house?
We'll put the 7,942 inside the house.
Very good. Okay, good to see you. Good to see you, Mechanical.
Put the 9 outside.
Yep. Ooh, there you go, Mechanical. You got your MT.
And then we see how many times can 9 go into 7.
Very good.
But it can't go into 7.
So what are we going to do?
At all. We put a 0 up top. And then we multiply 0 and 7. And then that's 0. So we put a 0 down. And then we subtract it by 7.
Uh-huh. So we can put a 0 down. Good. So what are we going to get?
We're going to get 7.
Okay. And now what do we do?
And then we see how many times 9 goes into 7, I think.
Mm-hmm.
And so it's 0.
Okay.
And then I think we bring the 9 down.
Good. Bring the 9 down. Yeah.
And then
Here, I can just make this look a little easier. 79. Okay. What's the next step?
And then I think we subtract it by 9, I think.
No. No, not yet. What did we do? We were saying how many times does 9 go into 7, right? 0?
Yeah.
But then we brought the 9 down. So now we're seeing how many times 9 goes into
9.
79. Big number.
Oh.
Right? That's why I brought it down. It's still one big number, right?
8.
Good. So where am I going to put the 8?
Below the 79.
Above the 79. I'm going to put it like right here. 9 goes into 79 8 times, right? 9 went into 7 0 times.
And then 9 goes into 8. Wait.
No. Not 9 goes
9
into 8.
goes into 7 0 times.
Right.
And then I'm pretty sure we do 9 times 8.
Good.
Which would give us 72.
Good.
And then you put the 72 down.
Good.
Below the 79.
Yes.
And then you do 72 minus 9, which is
well, no,
7.
Yeah, it's 79 minus 72, which you're right is 7.
7. And then we do and then we I think shoot, I forgot.
Let's just bring down the 4. So actually what happens after you do the subtraction, you don't need to figure out if this goes into this again because it never will. Because that was the whole point of you picking the 8. Is you picked something so that not another 9 could go into the difference. So every time you write a number down here, automatically pull down the next one. Okay?
Okay, so now we have 74.
Good. So how many times does 9 go into 74?
8.
8. Good. So then what do I do?
And then we put another 8. And then we do 8 times 9.
Uh-huh.
Which is 72.
Good. Where I'm going to put the 72?
Below the 74.
Good.
And then you're going to subtract 72 and 74,
Good.
which is 2.
Good. 2.
Well, 7.
So then what do I do immediately after that? What do I do next?
Bring the 2 down.
Bring the 2 down. Good. So that's a 2, right?
And then we do 7 goes into 22.
Uh-huh. How many times is
Twice.
Not 7. Remember it's 9.
9 goes into 22 twice.
Good. Which gets me what?
And we put the 2.
Good.
And then we put the 18 down.
Good.
I'm choking.
You're okay. Don't die on me, please. So then what do we do? What's the next thing? Are you actually choking?
Almost.
I was like, Mango. I can't do the virtual Heimlich for you, Mango, unfortunately.
I know. And then it would be, I think, 16?
No.
Wait, no, not 16.
What's 22 minus 18?
Not 16. Well, 20.
You got it, dude.
22 minus. Wait, no, I think it's. Well, 22 minus 8 is. Wait, are we doing. If I do 18 plus. I could do 18 plus what would give me 24?
Would give you 22, not 24.
Okay. Which it would be 4.
Good.
And then. That means 8 minus 22.
Yes.
Would be 14. So then my answer would be.
It would just be 4, right? 18 plus what gets me 22 is the same thing as 22 minus 18. It's just 4.
I know.
Okay. But what is this? What does this 4 mean? What does this 4 mean? Like, what's our final answer?
Our final answer is 8. Well, 0, 8, 8, 2.
You don't have to write whenever.
4
Plus 4 what?
Plus 4 9.
Yes. Yes, dude. Now here's a little quick tip here, Mango. You don't have to write the 0 here. You can just say this is 882. Right?
Okay.
If I said that you had like 10 bricks, would I say you have 0, 1, 0 bricks? Right? Same thing as just saying 10. See?
True.
True. And then actually, here's a cool thing. Do you know what 4/9 is as a decimal?
4/9?
Yeah, do you know what 4/9 is as a decimal?
As a decimal?
As a decimal. Do you want to know a trick? You want to know what 1/9 is equal to?
What?
0.111111111. It's really just equal to 0.1 repeating. Have you seen repeating decimals before?
Wait, so 1/9 is 0.1 repeat 9?
No, 0.1, but repeated
like
a lot of times. Like you just keep writing ones.
Repeated 9 times?
No, it's repeated infinity amount of times. Like it goes on forever. It's kind of a cool thing. You can have decimals. Mango, you can have decimals where the numbers like go on forever if you're converting fractions into decimals.
Oh.
Uh-huh. So if so that's what this bar means. Whenever this bar is above something, it means this just gets repeated an infinite amount of times. So like I could just keep doing this. Okay?
Alright.
So if 1/9 is 0.1 repeating, what's 4/9 going to be?
1/9 is 0.1 repeating?
Uh-huh. What is 4 of those? What is 4/9 going to be?
4/9. Point.
Yeah.
4 repeating?
Yes, dude. 0.44444. So if you wanted to write this, right, Mango, right, as a decimal, you could convert this to just 882.4 repeating. That's
Wait, 4 repeat?
0.4 repeating, yeah. Or, 882.44444. This is actually a cool thing about ninths. Anytime you have something divided by 9 as a decimal, it's just point whatever that number is, just repeating. So, like, for instance, what would 7/9 be?
7. Well, 0.7 repeating.
Good. Yes, exactly, dude. Yeah. Here's another cool
I'm
one.
gonna stay here.
What's up?
I'm gonna stay in the call while other people go.
Okay.
So I can jot notes.
Good. Well, dude, I'm glad. That's nice. That's nice, Mango. So, did you learn stuff? You learn stuff, Mango, here?
Yeah.
Yeah, hell yeah. Okay, nice. Good job, Mango, dude. You get a bond coin for that. Thank you for asking your question. Hope everyone else who was watching that picked something up. I mean, long division is one of those things where, like, honestly, like, I forget it half the time because we don't really use it because we use our calculators. But if you're, like, out somewhere and you don't have a calculator, you don't have a phone, like, it's useful to be able to do this by hand. And then this thing with the fractions, with the ninths, it's actually kind of funny. That's something I learned because when I count out how many shrimp that I eat, the serving size for the shrimp is 9 shrimp. So I always know like how many like extra shrimp I ate as being like point whatever that is as a decimal repeating of that amount of shrimp. It's kind of it's a weird thing, but that's why I know that a ninth is 0.111 repeating, because anytime I put into like, oh, how many shrimp did I eat, I have to say, oh, did I eat 2/9? I ate then 0.22222 of what a serving is. Oh, thank you for the Obama redeemed hydrate, dude.
That was dope. What was that?
That was Chewbacca. He's a Wookiee. You ever watch Star Wars?
Yeah.
Yeah. That guy? Chewbacca?
Yeah. I know who that is, but I'm talking about all the other stuff before that.
Oh, yeah. Yeah.
Alright, I'm back.
All right, Mechanical dude. You got a question, dude? You were next. What's up?
Yes.
Okay, what's your question, bro?
Geometric sequences.
Again, bro. Okay, cool. What's up? What's the question?
And this time, right? So, like, you already know how it's like AN equals A1 R to the power of N minus 1, right?
Uh-huh.
I want to find the 1000th term.
The 1000th term. Yeah. Didn't
Wait,
we... Did... Yeah, keep going.
Wait, 1000th term. 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 10 Yeah, with fractions. And we have to find the term.
Okay, that's cool. Because we did this last time with the 100th term. Okay, so what happens? Do they give you two different terms and then they ask you to find like a third term? Is that what this is?
Yes.
Okay, cool. All right.
So they already give the whole thing. So it's like.
Yeah, what do they
So
give
it
you?
was like I think it was like 3. No, it was like no 1/4. Then it no, it was negative 1/4. Then it was negative half. Then it was blank, and then it became negative 3/4. I mean, then it became negative 1, and then negative 5/4.
Oh.
So first they wanted us to find what the third term was, and then that's when they wanted us to find the 1,000 term.
Oh. Okay. So you're wondering. Okay, cool. So first of all, what type of sequence is this?
Geometric.
Why do you think it's geometric?
Because we're multiplying it by.
By what?
We're multiplying by 0.25.
So you're saying.
Or yeah, just 0.25.
So between these two, I'm multiplying it by 0.25.
Yeah.
So that would be negative 1/4 times 1/4. That would be equal to what?
Negative 1/8.
No.
1/16. I mean, yeah.
Is that the same as this?
Oh.
Nope.
So it's arithmetic. Then.
Yes, there we go. Yes, dude. Yes, it's arithmetic. This is not geometric. Yeah, this is also not.
You're right.
Okay. Well, that's cool. It's still a good question. All right. So then, now that you know it's arithmetic, this is a good point. Yeah, I should be like, what is the third term? And what is? Let's see if you remember it. The 1000s.
So
Okay.
I'm gonna do the explicit formula because I think that's.
That's what they call it. They call it the explicit formula.
They call it explicit, and then there's recursive.
Okay.
I like explicit more.
Okay, that's fine. So what's the explicit formula?
I'm gonna do A3 equals negative 1/4 times R. I mean plus D. Multiplied by 2.
Right, because it's 3 minus 1. Yeah. So the formula he used, guys, if you guys are wondering, this is AN is equal to A1 plus D n minus 1. Okay. I don't care, son of water. Megamax being a savage now, dude. Okay, cool. All right. So what am I gonna do here? What am I solving for?
Now that's 2.
Yeah. So this is 2.
We have to find D.
We've got to find D.
Find what D is.
We do have to find D. Yeah. How do I figure out what D is?
Don't we like go back to like the other numbers?
We do get the other numbers, yeah.
And then we like sort of like subtract or something.
Sort of, yeah. We could do that. So what you can do is you could always write out what the expressions are for this. So this one is what? A what?
A1.
So you know that A1, right, which is equal to negative 1/4, right, is equal to A1, right, which is negative 1/4, plus D times n minus 1, which is just 1 minus 1. So that's just equal to, right, 0. So that doesn't really tell us anything. That just says, cool, negative 1/4 is equal to a negative 1/4. Okay. All right. What if we look at A2, for instance? A2 is equal to what?
Half. Negative half.
Negative half, which is also equal to what in terms of the explicit form?
Negative 2/4.
No, negative 1/4, right? Because it's equal to A1.
Oh yeah, negative 1/4.
Plus D times.
D times 1.
Right, because it's 2 minus 1. Okay, cool. Do you see how this is an equation now that I can solve for something? What can I solve for here?
You can solve for D, right?
Good. Yeah, I can solve for D. Yeah. How can I get D here?
No. It's that one word. It starts with the letter S. It's
substitute.
Substitute.
Well, I only need to substitute when I have 2 equations and 2 unknowns. I really, this is easy. I'm just trying to figure out one thing. This is a simple algebra thing, right? Look, -1/2 equals -1/4 plus D. Solve for D.
Oh, we subtract.
Good. Well, not subtract. You got to do the
Add,
opposite.
basically.
You got to add. You always got to do the opposite of what's happening, right? So this is subtracting
I forgot
quarters.
that it was a negative.
Yeah, it's a negative. So what am I going to do?
You're going to add both sides.
Good. Add 1/4 to both sides, right? Okay, now what do I get? So this goes away, right? But what's -1/2 plus 1/4?
-1/2 plus 1/4.
Mhm.
So it's going to be -0.5 plus negative.
You want to convert it to decimals? No. Come on.
So won't that just become another -1/2?
No, close.
It will be
Lauren Rod, what's up, dog?
a -1/4, right?
-1/4, yeah. So again, if you need to add fractions, you always got to make sure they have the same denominator. So -1/2 is the same thing as -2/4 plus 1/4. Do you see this? Do you see how now you can add these together?
Mm-hmm.
-2 plus 1 is equal to -1/4.
Yeah.
Good. Yeah.
So now that we know that D is 1/4.
Now it's -1/4. Remember that?
-1/4.
D equals -1/4. Cool.
Mm-hmm. So then now we just plug it in.
So yeah.
This will become -1/4 plus -1/4 times 2.
Times 2. Good. So what does that get you?
So then it will become -1/4 plus -2/8.
No. That was if it's 2/2, you'd multiply both.
Oh yeah, then it becomes -2/4.
Good. Plus -2/4. Lauren Rod, dude. God damn it, Lauren Rod. I love you, Lauren Rod, dog, but like you can't be saying this stuff in my chat, please.
You're like Grim.
Lauren Rod is worse than Grim. Someone who's a mod, please take that off.
Got you.
I don't. Thank you. Thank you, Nick. Ooh, see, Nick's doing work this time. Nick, thank you, dude. Nick is doing his work as a mod. Thank you. I actually don't even know how I delete stuff. I can't even do it for my panel here. Lauren Rod, be nice. Else, I'm gonna kick you from the chat.
Hold it or like side click or like right click it, and then it'll show you like if you wanna time out him, ban him, delete his message, or ban.
Hate on Lauren. Block. It's not hate on Lauren. No. No one hates Lauren Rod. They're just like Lauren Rod. Just you gotta keep it clean. You gotta keep it clean in the chat and stuff.
Don't do that, unicorn fart donut.
No, you know that. Yeah.
Oh yeah. I mean Ash.
Ash.
Before,
yeah. Yeah. Okay. Whatever. All right. You're good. All right. So what? -1/4 plus -2/4. What's that gonna be?
-2/4 minus -1/4. That's gonna become -3/4.
Good. There you go. Okay, what if they ask for the thousandth term?
The third term is -3/4. Now we gotta find for the 1,000th one.
Yes, good.
So now we just replace the 3 with the 1,000. So A1000 equals -1/4 plus -1/4 times 999.
Times that, yeah. So what does this become?
It becomes. Hold up, this calculator is being mad sped right now.
Nick, you feel free to delete that. You can also ban him from the chat.
-249.75.
-290. What? Oh, that's what it comes out to be. This is also what it is. It's -1/4. Minus 999/1/4. So actually, yeah. So this becomes -1,000. You see this over 1/4, which is wait. This is equal to 250. What'd you say? It was something with 75?
Mm-hmm. I didn't do minus -1/4. I didn't do that. I was just doing the multiplication.
Oh, okay. Yeah, but see how this -1 minus 999 becomes -1,000, and then this is an easy thing. Like 1,000 divided by 4 is just 250. You know, it's like $1 divided by 4 is $2.50. Cool. Does that make more sense? Yeah. Good job, mechanical. Okay, cool.
I had to mute.
Lauren Rod for 600 seconds. Yes, thank you. Thank you, someone, for doing that.
Yeah. How do you do that? I'm nice like that, Nick.
Yeah, it's all good. It's all good. Dr. Gold, what's up?
Ooh,
Love Zach. What's up, dude? Drink water. You right. Thank you. All right. That's it. That's the end of office hours.
That's dope.
That's dope. Thank you, everyone who joined the stream and asked some good questions today about math and science. I really appreciated it. It was what was it? Man, I'm fried at this point. But yes. Thank you, everyone, for joining office hours. I think our next one will be tomorrow at 3:00 Pacific time. If you want to join, it'll be the last one of the week, and then we'll do them again. I don't know if I'll do a stream on Monday actually, because I'm getting LASIK on Monday. And I don't know if I'll be able to look at screens after that. But
I might be streaming on Monday.
Okay, cool. Then maybe we'll have mechanical stream. We'll see how I feel. Let me see. I have my surgery in the morning, so let me see how I feel after that. Okay, awesome.
I basically stream every single day now. So
yes, dude. Yeah, you get that view count up. Nice. I saw lots of great applications for the student teachers. Thank you all for that. I promise I will go through that over the weekend, and we'll start announcing who we're selecting for that next week. And then for the monthly tourney, I know I've been slacking on that too. I need to come up with another competition for you guys to do. It's hard. I would like to do a private match, but I think we need 20 people for that, right?
Yep.
Man, maybe that's what I should do. I should try to see if we can get 20 people, you know.
Darn. Out of all 720
Yeah,
players,
can I get 20 kids to play Warzone? That's a good question. Maybe, okay. I'll think about it. Maybe I'll put an announcement out, put a feeler out there, to see if we can get 20. Mega Meg says he'll be one of them. Yeah, Jack's calling me. Jack, I can't answer the phone right now, dude. Give me a second. Jack, I'm on the stream. All right, cool. Does anybody have any last minute questions before we go?
Yes.
Yes. What's your last minute question?
Follow my Twitch.
Follow his Twitch, dude. Yes, dude. Yes, follow the Mechanicals Twitch. Yeah, if you're joining us from Twitch and you don't know about the Discord, be sure to join the Discord where we have tons of cool stuff. We're giving out prizes. I gave out a couple gift cards today actually, for people who are earning bond coins and getting enough for the prizes. And we announced.
Can I ask the same question?
Yeah, what's your question?
The same question Mechanical asked.
Oh, are you streaming Mango now these days?
Yeah.
Nice, dude. Post your here. I'll add you to the streamers list. So we have in the Discord is like whenever you guys stream, it'll make an announcement in the gaming channel that you're streaming, and it'll also give you a special role. It'll give you the now streaming role, which is cool because then people can see that you're streaming.
Yeah.
But yeah, Mango, post your can you post your stream in the stream link in the self promo channel so I have it, and then I'll add it to the roster.
All right.
Cool. All right. Nice. Okay. If anyone wants to play a couple quick games, I have a little bit of time to play video games with you guys. Otherwise, I'm getting ready for this festival. I gotta throw over the weekend.
I can't. I have to go back to
Okay.
Minecraft
All good.
world
I'll play some
make
Fortnite
some
with Jack. Jack
improvements.
loves to play Fortnite.
Wait,
yes.
who has a mic?
But anyways, okay. Good to see you guys. I'll see you guys tomorrow.